G'day guys, going to show you something about any coil that has multiple windings in it. This one here is basically one transmit winding and a receive winding going into the two separate channels on this detector there, which is in mono mode, and I've just got one of these out of phase, so it should cancel all the noise, and you can hear it, I hope. It's drifting around a bit, but it's picking up some sort of, I think it's a computer or something. It's a hot day today, and if you can hear that noise, hopefully you can. Actually, what I'll do, I'll put on the other microphone if I can get it. I've got another one of these things, so I'll turn it on. It does act as a dual channel. Hope it's not too loud though. So you can hear that racket, and I've got the coil sitting here, and see, I've just got them a little bit bent, a little bit on an angle. I don't want to get the iPhone too close because it'll pick it up easy. Okay, if I get one of these coils and I balance it like so, and I get them relatively perfectly straight, even though they're far enough apart, whatever the interference is hitting both coils in the same plane, same intensity roughly, a little bit out, but it basically has cancelled a lot of the noise, and we just got a little bit of residual noise there. If these were brought closer and, you know, put in the correct format, not like being so spread apart, they would more than likely cancel out all the noise. So if we just took that, if I just went to one coil, I can do that here. Well, actually, what I'll do, I'll throw them back into phase by putting this in cancel. Right, so this is both coils in phase. That's the noise that's coming through. Okay, and what I could also do, I could put into double D. We've got two coils, it's on the double D channel as well. And so the way I've got rid of the noise is running counter-phased coils on mono, right? But the thing is, because one's just receiving and the other one's transmitting and receiving. Okay, that's the transmitting one, and this one does sweet FA. But what you can do, and I just, you know, I was playing around with this because I did it on another video and I said, oh, you can do this and do that and whatever else. How about I put it there so it doesn't fall off, and I get this one and I'll put it directly underneath. So if you can imagine that as a coil, this is towards the ground obviously, and this one's up in the air. You know, maybe you get something like that and you just put it on a piece of PVC tube and have a vertical coil. Because that receive one is so far away from that top one, let's get our little test target. It's actually as sensitive as a mono, but you haven't got that signal subtraction by using cancel mode. As long as that other coil is not really very close to the top one, you can basically get rid of all that interference. Like I say, if I just put these back into phase, there is a racket and a half. It really is noisy. And imagine, like, I'll just do it again because it's rather spectacular, the noise reduction. Okay, so this is in phase. And that's bringing both channels on mono, so there's no phase change done in the detector. The phase change is done at the coils, right? And isn't that nice? And the thing is, how much offset laterally can we get before it really starts spitting the dummy? Because on a bigger target there may be a little bit of cancellation, there may be, but it has to be this far, and I don't really think there's going to be much. But if I get this coil here and I'm going to move it right over, let's see if the noise picks up. Probably, I don't know. It has picked up a little bit, but we're right off now. You can actually have an offset vertical coil stack, and it'll work fine. Let's put it back. I haven't even done any ground tuning on this. I don't know actually how it's all set up, but I don't even know what mode I'm in. I'm just doing it for the cancellation effect. What I'll try it on a bigger target. How's that? How about I'll try it on a ring. Doesn't care. I'd say you can do this with any size coil, by the way. Doesn't have to be that small, but you make a pancake coil assembly, and just remember, the bigger the coil, the greater the distance you must have between the two coils, or else you're going to get cancellation of the target signal in the other coil, and the other trick is then to offset. So the interference is drifting back hard now. I can hear it, it's picking up, but you know what it's like without. There we go. I'll put them back right next to each other so they're getting the same amount of signal in the same plane, same orientation, as close as I can get it. I'll put it over there. It's pretty hard. I've got the wires pretty short between them. But give you an idea, at that distance, the interference we're getting is, I can just hear a little bit of AC mains come through. And what else can we do with these? You can make them into a double D type configuration, not that it's two Ds. It's far more efficient like this, by the way, than running a D as such, and it'll be sensitive as, hang on, we'll just get my stick here. I'm doing all this by hand, so here we go. Yeah, we're getting that sensitive in the middle part between the two. Not that there's much there, it's like a few millimeters. So it starts acting like a double D. And we can do this. You can experiment with the placement. Sometimes you really need to look on an oscilloscope where you get the null on the receive, but we can do it like this. And notice we get two signals because we're getting the mono response and we're getting that response from where the crossover is. So it's very interesting. So there's a lot of experimentation that can be done with coils still. Doing the phase change on the coil, and don't do it in the detector by using cancel mode. Let's try a ring. Let's get the ring again. Well, I'm right up in the air. No problem on that. Hang on, have a listen to this. It does give a double sound off, because it's not acting like how a double D does, and it's a large target close to those coils anyway. That gives an idea what you can do. Now, if I got one of these coils, say I got the receive one, and I changed the plane of the coil, and I put it up vertically, so it's intercepting the electric and magnetic fields from wherever it's coming from differently. Let's have a look and see what happens. So we do this. Yeah. That's to be expected. Even if I turn it around the other way, it won't make any difference. Well, it makes a bit of difference. There is field coupling there. The interference, it's still picking up that mains. I'm actually probably aiming at it, and we've got no cancellation effect. Hang on a sec. Yeah, it's probably magnetic field from my workbench. Yeah, it sounds like mains interference. I'll put it around that way again. And the other thing, like I was saying with these coils, you've got to get the phase right. Hang on a sec. One's wound clockwise, one is wound counterclockwise. You can't wind these coils in the same way and then tip one over. It doesn't change phase. Like if I got this, right, that's basically using a mono. It's got to be wound counterclockwise, because when it goes around the other way, it shouldn't make any damn difference, should it? For some reason it is, I don't know. But you can play around with these configurations. There's nothing stopping you running a separate. I'll turn this off, it's bloody noisy. I'll turn off my booster as well, because it's noisy. And yeah, I can't spin this around. As soon as I touch the thing to spin it around on the camera, it drops the video. And I'm not really set up for video stitchings, so I don't do it. But anyway, you can actually run a separate transmit cable from the detector, and you then get two separate receive cables, and you can make a really good OOO coil, couldn't you? And if you want to play around the phases, you can run them in phase, use the detector to run the receiver out of phase to 1 for noise cancellation. That would actually, I'm just thinking of the configurations here. First of all, I'm going to tell you something as well. I got an email from a company. I'm not going to make mention of the name, but they asked me to do some work on coil design for them, and I refused. I'm not going to do it because there's still a lot of little trade secrets in this coil business. And yeah, so you can, guys, if you really want to start mucking around with coils and coming up with new stuff, do what I said there. Remember, in these older GPXs, you have a separate transmitter. You have two separate receiver wires on your coil plug. Okay, you can combine them and run it in mono mode and get the benefit of having two matched input stages, which should technically, but doesn't, give you 3 decibels noise improvement. For some reason, yeah, it skews off a little bit, but you've got to get into the detector and you can match that so it does work properly. Everyone knows that. It's been proven many a time. And the other thing is to say you do want to have 2 separate receive coils. You could have both of those coils reverse phase to the transmit coil, or you could have one in phase with the transmit coil and the other one out of phase with the transmit coil, and then you could put it into mono mode and pick up on the transmit coil with the coil next to it, right? And the other one's basically just listening for the noise. and you will get good noise cancellation. So you can make this these a 3-coil detector. You could also, if you really wanted to, you could make a separate transmit loop, a bigger outside receive loop on a separate input, and a smaller one as a concentric in the middle on a separate channel. And all you need to do is you need to have extra damping on that um, on the coils that are not connected into the transmit stage, because the transmit stage has the damping resistor for the back EMF from the transmit coil. But because there's still close proximity, you can't have a ringing coil. The coil still needs to be damped. So those, either or both of those outrigger coils, however you got it configured, you'll need to put a 1K, a very, very small 1000 ohm resistor across the windings on each coil to dissipate any ringing of that coil, basically shut it down after the transmitter turns off. You can experiment with those values. 1K is a yardstick. I have seen them down as low as 250 ohms. I have seen a lot of them at around about 580, 600, 620. You can just configure it to see what works the best. You know, you could, if you just put some plastic potentiometers on there, right, with the plastic where they normally have the carbon, and that it's just plastic. It's a conductive plastic, and yeah, for some reason they're usually a blue plastic pot. You can put those on and just twiddle to your heart's content doing experimentation. The other thing as well, you could, if you got really cheeky, is make up 2 little subboards with small MOSFETs on the board, and parallel it to the MOSFET that dampens the transmit side, and just run off the gates. Use a 100 ohm or a 10 ohm resistor just to keep isolation there, and basically switch another damping resistor in and out of circuit on both receive coils from the transmit, because the whole thing, you can do it all at the same time, because you know you really don't want any resistance across the coil whilst it's in receive mode, even though the input to the detector is a very low impedance. You know, it's very low, and you know, 1000 ohm resistor is not going to really do anything. It could, but I've never gone down to, you know, what do you want to call it, like those nanovolt type voltage levels. I haven't done it. So you could play around and do that. I'm just coming up with ways you can all experiment. I think there's massive possibilities still in these older GPX and GP and SD detectors, especially the GP. Anything with the cancel mode set up in it, with it's already there for you. You've got 2 input stages, and you can run them in phase, out of phase. You can parallel, you can series, you can do whatever you want. You can stick your transmit coil a mile away from it all. And there are more things about these detectors that you can do. And I don't really want to go there because some of it is very commercially sensitive. It really is. That people don't realize. But anyway, that's that. So play around with coils. You know, you can make a configuration up that looks exactly the same as what's in the GPZ coil. You can make a configuration that looks like that. Well, basically, you could probably gut a double D coil, right, and just put on another double D part of it, right, and you can run in phase and out of phase. And yeah, I'm just saying, this is just my opinion, right? You could actually do things like flip the phase of the 2 outrigger coils every alternate transmit pulse. It's sort of, you're doing what that would do is change the phase of the two outrigger coils without, you don't, well, you know, the GPZ, ZZ, whatever I call it, flips the phase of the main transmit coil, and you could electronically just put a any sort of well, you want something really good. You want something low on resistance, low noise, and very fast switching. But some sort of mucks in there. You could use a 4051 or something like that if you really wanted to. I get an ADG somethings. What are they? Not the 602s. Too many ins and outs on those. But you could get the smaller ones of those. They've got very good specifications, and you could flip the phase of your outrigger receive coils, and like I say, you may get some interesting benefit from ground response by doing that. Like I know, I've really opened up the freaking Pandora's box, haven't I? Because this sort of stuff is, no one's done it. I know no one's done it because it's not out there. No one's done it. No one I know has ever done it. So all you coil experimenters, if you've got a GP or a GPX, any model before the 6000, you can do all these phase flippings on the coils very simply. Not hard. You can do it. You just got to make little boards up. I hope someone makes little boards up for people to do it. Only if it's not covered by a patent, of course. If it's patented, oh, you're not allowed to do it. But there, I just put in the disclaimer just in case, because you never know in this world. You get people go, oh, he said that, let's get him. Yeah, 100%, 100% true. If anyone thinks they can make $1 out of you, right, they will. They all bloody will do it. So be careful. Put your disclaimers in there. And like I say, it's only my opinion, right? Got no idea if it would work, no idea whatsoever. I'm just guessing. I don't know. So anyway, that's the disclaimer. But you can muck around with these detectors because you got 5 pins in the plug. Think about it. You have basically you transmit and your active transmit and your return on 2 wires, the first 2 on the plug. Then you have 1 receive channel that's usually shorted to the next wire on the shorted to the transmit side, so it's all running. That's how monos work anyway. It's all connected together, and you can also connect the second one as well. But you do that in the connector. So, and then you have a separate non-noisy ground, we'll call it. It's an isolated ground where all the low noise componentry is. That's the yellow wire normally inside the detector on the 5th pin. And so you got 5th pin, which is low level ground. Don't connect that to the other ground in the connector on the coil or anything like that. It'll introduce noise. Then you have the next 2 is 2 separate receive channels. Okay, I think that the first one, the yellow wire, the number 5 is low noise ground. Okay, so you only use that to go to the shielding of the detector, just the shielding the right up at the detector onto the Faraday shield. The next wire in is what they normally use for double D function on the double D side of the coil only. Okay. Next one is receive and transmits bridged, and then you get the first wire is the wire they use for high current grounding. So don't connect high current grounding. Basically, do not connect the black wire, big thick black wire in a coil connector or the braid to where the yellow light duty wire is, especially on the mono. It doesn't make any difference really, but on the double D it does. So it is a separate ground. It just keeps the noise out. It alleviates switch mode noise, processor noise, pulsing, any other noise generated in the detector getting into the supply lines and coupling into that ground point. So it's a low noise ground. And yeah, there's a lot of other detector manufacturers out there don't realise that. Anyway, cat's out of the bag again. And they just couple it all together as a hard ground, and they can't work out why they can't get good noise figure, specifications with their detectors. They can't get as good as a Minelab. It just falls over. So separate grounding is important, in my opinion. In my opinion, it's always in my opinion, right? So you can do a lot of mucking around, with these detectors, and there's nothing stopping you. You don't need. I'll tell you, right? You can get double D cable, but that double D cable is a bloody compromise. It really is. It's got higher capacitance, and it is not super thick. It's got a bit of resistance through it. It's okay. Depends where you get it from, of course. But do what I do on this one. If you have a look, I'm getting close so you can see. I just use 2 mono cables, right? And I'll hold this up so I've got the lights on in here. It's damn hot. It's 30 something mid degrees, I don't know, but it's cooking. So that's just how I've done it. I've just soldered basically like a mono type setup with 2 coils, but I've got them on separate receive channels. You can see that works quite well. So there's no excuse not to experiment with coils and keep these, these GPs and GPXs, the earlier models, going strong, because everyone wants less ground response, less ground noise, and you want to be able to get rid of interference. So there's a lot of experimentation to go on here. And even saying what I've said, I bet you it's going to cause a ruckus in the industry, because people are going to start making coils that can be phase flipped in this design of detector. You need the cancel mode to phase flip it. So, but you can make up your own cancel mode circuit anyway. It's not even hard. All you got to do is use something like a 4051 and just configure it so it just flips the phase of one of the channels. Very easy to. All you need is that. You just need another op amp. You just phase flip it. It's really, really simple to do. So using the 4051 as a switch, and just use another op amp set up in inverting configuration. Just basically shove the thing together in a way that it doesn't actually give any extra gain. It just maybe gain of 1 or -1, however the configuration is, and you can just match up the other one with a resistor, or just change the gain on the op amp on the input stage. Whatever you want to do. I'm not going to say which way is the best way of doing it. I'm just giving ideas on how to configure it. But you could do it with any detector. You can go do it with an old SD2000 if you really wanted to. There's nothing stopping you, adding a damping MOSFET in there if you really wanted to. You can do that switched in, switched out, because you can pick the control points off the 4093 right up near the input stage, and you can use that to control the MOSFET and get rid of that damping stage, which goes hard to ground, which is always on the receive line. You could get rid of, or basically put a what is it, 680 ohm resistor in there, whatever it is, and get rid of all those other resistors. You don't need all that. Just go that and switch it in and out of circuit. You can probably add delay as well, or get another 4093, and you can add delay with those two, with just basic a simple RC network on the inputs, so you can delay it if you need to. But like I say, it's all out there for experimentation. But I like the coil idea better. You can make all sorts of configurations of coils. You really can, and that's where some of the magic is done in the coils. The coils are very, very critical. Like I was saying in my previous video, if you have a winding which is relatively higher resistance than normal, both receive and transmit. You can't get the power in. You can't shut it down quick enough. And if the wires are all bunched up, it's higher capacitance. Things don't switch quickly, and there's residual held. Capacitor stores energy. You do not want the winding storing energy whilst it is going into the receive mode, because it's going to have energy die off and it's going to desensitize your receiver if it's coming in that quick. Depends how many microseconds you take to sample, and you could say, well, I'll sample out at 15 microseconds. That'll give plenty of time for all these eddy currents and that to die off. But the thing is, when you do that, you won't be getting very, very tiny gold, because its eddy currents have all died off in that time period. So you want to try and bring it in, shut your coil up and down and shut it up really quickly. And as a real eye-opener, go and have a look at some of the technical write-ups on ground, on dirt and ground, no matter what type of ground, no matter what the ground is made of. It's very interesting how the ground is explained. You've got to read some of the newer research on this, and it's not all as it's been portrayed to be in the past to a degree. We hear all this stuff about, the ground takes ages and ages and ages to die off. It doesn't, because it's ferrimagnetic. It's not ferromagnetic. And it just dies off. You can probably get some additives in there that may sustain the ground die off, but I don't think it's such a big deal. I was reading some very interesting papers on it on ResearchGate, and it's all under the anti-mine genre of papers. So you read about mine detection, demining, and read about the ground. There's a lot of very, very smart people who've written up a lot about ground, and especially if demining. You don't want to get it wrong, do you? You don't want to miss that firing pin, or else boom-o. But it's all interesting. People need to, in general, do their own research on this stuff. If you really want to find out the nitty-gritty of everything, use Chat GPT, or use the new one, Gemini and Chat GPT, get it around the right way, you're not dyslexic, is very good if you ask it specific questions, but you've got to put in a lot of detail of specifically what you want it to work out. Like, you can't just go and ask it something simplistic. It'll give you a very simplistic and totally off tangent answer that makes no sense. You have to tell it a story. You have to tell it, you can't say, I'm using a metal detector. You got to say, you're using a metal detector, and you got to then tell it, it's going to transmit pulse length for this, the coil inductance is this, and we're looking at a ground type of this, and there are particular magnetic measurements you can make of ground. I've got something out in the garage that does magnetic measurements of ground. It's basically a 2-coil oscillator thing, and you put dirt in the middle of it, and it gives a reading. I can't remember what it's called. It's got some name. But if you want to buy one, it's very damn expensive. But yeah, you just give it, have a look at data. Get data off the internet, and have a look at the ground makeup, and put the information in there, and it will give you answers. It's can be quite good. I've actually, when I was using early on, I was using the Chat GPT to do some workings out, and it was just given absolute rubbish. And even some of the stuff that sounded likely, right, I would try it out. It wouldn't work. And I'd go, what's going on here? And it was, in particular, that I wasn't giving it enough information. I knew in my head what I wanted to do, but it's like what I've got in my head, I have to transfer all that into the AI program. And you tend not to do that. You tend to just give it the shorthand version and say, I want to do this, but it doesn't know. So I was running both of them. I was running the Gemini. There's another one too, and I was comparing results, and it got quite interesting. Then I was feeding results from one into the other and cross-referencing that way. And I was telling one that this one said this and this one said that, and giving each AI the other one's information and telling it. And then it really went to town working on it and absolutely coming up with lots of scenarios and working. They're like the AIs are trying to outdo each other, even though they're completely dumb as such, right? But it was really funny. Anyway, you can do that. You can even ask it to design coils for you, but you've got to give it a lot of measurements, and you've got to tell it that you're going to separate the wire by X amount and this much turns, and if you're going to run glue in between all the windings, tell it the dielectric constant of the glue added into the equation, or else you're going to get coil that doesn't work as well as what you think it does, or just lower the self-resonant frequency, which it's not usually a good thing. Lower the Q of the coil usually means it doesn't work as well. So there's a whole heap of stuff there, tons and tons and tons. Anyway, with this coil and coil saga, I hope everyone gets out there and starts experimenting. I don't know if Hayes Electronics in the US still exist. Hayes Electronics sold coil shells. They were very cheap. You could actually get your own coil shell and get a bit of foam and cut it and whatever and make your own coils. Get your coil. If you want the mono cables, we got mono cables. They're on detectormods.com on our website. We got the Litz wire. If you want Litz wire, detectormods.com. See up there. I'm not going to touch the screen to make it bigger because it'll probably cut the video off, as it has done in the past. But yeah, there we go. We do have a lot of stuff on our little web page. David's probably there putting dongles on it at the moment because people are saying, I can't find the dongles on your web page. So that's his area. He does all that. So yeah, you can probably see all the parts I use too in detectors. If you can, get onto that. But there's more up there as well. They're all over the place. There's more there as well. There's more there as well. There's tons of stuff. I haven't got enough room in here. But go nuts, guys. Go and experiment, because you're probably going to find something out that no one knows, no one has discovered, and you could make something really good. And if you I'm going to be terrible and say this, if you kept it to yourself, you could really clean up the goldfields, couldn't you? But that's not in the spirit of the hobby, is it? Locking stuff up so people can't experiment. Patenting the crap out of everything. It's really funny. You look at some of the patents around the place. Like very early on. I'm talking, God, 20 years ago. I was putting little ferrite tubes, over the solder joints in my homebrew coils to stop the solder joint acting as a target within the coil. Basically, if you have a solder joint on your wires and it's actually very close to the coil windings, if it moves, basically something the size of a bee stick, it's going to sound off like crazy. So what I was doing, I was putting them in little ferrite ferrules. Not feral animal, but a ferrule, little tube. And by putting that in there and just going, squirt with hot melt glue, it would lock it in really tight, and that would have no interaction with the windings. So it was like it wasn't there. But then some years later, I saw someone somewhere trying to patent doing that. But anyway, it's just amazing what gets patented. So sometimes you can say something and it'll first in, first best dressed, or whatever they call it, and they'll apply for a patent. It used to be that if a patent was, or we won't say a patent because it wasn't a patent. There's not, it can't be a patent to start with. If someone does something, right, it used to be like this. Say I went and said, well, here's this detector design, and I've done this and I've done that, and I've taken this very novel approach that no one else has ever done, because there's no record of it anywhere. And then you get that and you put it out on the internet, you put it everywhere, right? Usually it was classified as prior art. It was well disseminated through the community, through the groups, through researchers or whatever, and you couldn't patent it. It was already out there. But what's happened now, as far as, in my opinion, and as far as my patent attorney has told me, right? Yes, we do have patent attorneys. Oops. Of course we do. What he said was that some law was changed, and now, no matter what is said anywhere, it's first to file. First to file means if you file and it goes through the system, right, you will get that patented, even if it's something from years and years and years ago. The only thing you can't patent is things that are obvious. It should be obvious to people skilled in the art. I never thought you could patent putting ferrite over wire joins to, reduce the interaction of that in the windings, and also stop that component or that join generating eddy currents coupling into the windings. I thought that was just obvious. I thought it was dead obvious. But, I'm led to believe that that could be, or was attempted to be, patented. I'm just amazed. But anyway, it's what it is. It's my opinion. I'm amazed. It's my opinion. I was amazed. Okay. It's my opinion that everything I said is just my opinion and is not factual in any way, shape, or form. It's my opinion. Okay. So I'm telling everyone it's my opinion, just in case someone gets their nose at a joint, which you never know. Some people can get very, very easily triggered in what you say, and will try and use it against you. But anyway, I didn't mention any names, did I? Just out there, some obscure patent somewhere, I don't know. But that's what it is. It's what it is. And there are other ways of doing it, by the way, but I'm not going to mention it because you know what'll happen, don't you? It'll be run off as first to file. That'll be the end of that. So a lot of things you've got to be careful what you say, because people will jump on it. Like years and years and years ago, there's a particular forum. I'm going to say it anyway. There was a particular forum, right? And basically I was talking about induction motors and how you kill the induction motor very, very quickly. Okay? And what it was is that to get really good power, this is mainly through big DC induction motors. What you would do to stop that motor turning when you turn it on using a silicon controlled rectifier, look up an SCR. They've got a little gate on them. They got a very low voltage drop, and they will do, some of them do thousands of amps, right? The trouble is, once that SCR is in conduction, you can't do anything with the gate to turn it off. You can't go, oh, hang on a second, we'll take away the voltage from the gate terminal. No, it's in full conduction, right? Actually, it's quite dangerous because there's no way of stopping it unless you have a huge contactor, which you can operate to break it. Sometimes they stick, and that's a dangerous situation. And the other way of doing it is just have a manual slam button, which just breaks the contacts. So it just takes away the power from the device. But what was the early days of doing this? What you did with this system is say it was working on 50 volts. you'd have a very small turn transformer in the primary going to the motor. And what would happen, that would go bang on, it would turn on and induce a voltage, and there would be another winding, many hundreds of turns around that, and that would go into a capacitor. And usually you'd ramp up the voltage via the transformer into the capacitor. For memory, I think we put 200 or 300 volts into it, and it's a very low ESR paper capacitor, probably 200 microfarads or something. It wasn't very big. And what we did with that is use another set of SCRs to dump the energy out of that capacitor across the big SCR, right, in reverse polarity. And that tiny instantaneous pulse of energy dropped that main SCR out of conduction. It turned it off. So if you ever looked at older electric forklifts and stuff, they'd make a tap, 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 tap sound, and that's turning the SCR on and off, and that's the magnetic field collapsing and coming on in the coil as such. Anyway, I did a big thing on a forum about this, and that actually triggered off a lot of research in some particular detector designs, not using SCRs, of course, but basically turning things off and on. And I'm pretty sure it then resolved its ways into bridge drivers and things like that. But anyway, I'm not really worried about all that sort of stuff. I think all you need to do is tickle someone's imagination with something, and then they'll go off and something may come of it. It's just what happens. Most inventions are not a planned invention. They're basically doing something and something else happens, and it's a discovery, and then it turns into an invention or whatever. But anyway, that's enough waffle. It's bloody boiling in here. I want to go out and sit somewhere where it's cool. Not outside because it's boiling out there, but I think it's time to go upstairs and crank on the air conditioner, crack some beers and things. Anyway, hope you like that about coil configurations and what you can do with these older detectors. Yeah, so someone should put up a group or something on the web about mucking around with this and just have nothing but mucking around with detectors like this, because I don't think there's anything that really exists. It's all, this detector, that detector, this coil, that coil, make this modification, this amplifier, this whatever, but nothing really specific on the coils. Maybe everyone should migrate over to the coil section on Geotech, on the Geotech website, and if you want to go over to the Geotech, it's called Geotech number1.com. Go over there and register as a coil section. If you start experimenting, you can put your findings up there and read everyone else's stuff. That's my idea. I hope Carl Morland, who runs the site's watching. He can probably help with that. Anyway, I'm only an email away. Anyway, that's enough of this. Catches.